Okay. So, I wanted to share a little bit of a fun experience that I had recently. It's not about teaching performance or anything, but it's more about the side effects of thinking about it too much, maybe. So let's get started. Um, how can I change it? Oh, okay. So I joined the micro interactions contest thinking about performance, the usual stuff like CDN, cache, code splitting, compression, unification, and so on. But if I had to explain it to my wife, it would be something like, I want to make the user feel good. And it was somewhat funny because I was also thinking about performance while trying to build a ray tracer, but none of the standard metrics we usually use here mattered. The performance was crap and I couldn't render a simple sphere. So after some time, some months actually, I realized that I was wrapping every problem with my web developer's mind, trying to solve everything with the same mindset, thinking about the usual performance stuff I just talked about. And then I remembered of that golden grammar problem. If the only tool you have is a grammar hammer, it is tempting to treat everything as if it were a nail. Like when I need to format a username, when I need to format a username, date, or title on any web page, sometimes I pick the most beautiful function. Like I even organize my code by shape of it, so it can look like a Christmas tree, a ball, or a sword, you pick. So because a good performance in this context is basically when it works on your machine, on my machine, like in this case. That's what I did with the function on my ray tracer that parsed all the final pixel colors of the render. It had a beautiful, like asymmetric curve with a tiny chained methods in blue, all beautiful, but it was taking forever to render a simple image when it should do in a few seconds. I ended up reducing the render time after a long time. I reduced by more than half after finding a better way of building the image file on my disk. So my first lesson was learned. Performance can have different meanings in different contexts. So let's go to the next chapter of my life. 132 commits later, as I checked and I remember, I had a lot of functionalities implemented and my ray tracer was doing tons of calculations. It was too slow again, and I started blaming the language, the universe, the vaccines. So I took the same approach as before, and I started logging everything. But it was taking ages to find the issue this time, so I decided to give it a try at the node profiler, and it worked. And I could find what was happening, and the problem was this: I had lots of spots doing small harmless calculations over and over again. The code was extremely easy to read, and anyone could look at it and understand what was going on without much effort. But that was the problem. The code was optimized for readability and not for efficiency. That was the first part of my lesson too. So in my first attempt to fix it, I cached every calculation I could, and the ray tracer was eating 8 gigabytes of RAM to render a 100 pixel square image. Look at that. But after cursing the JavaScript again, I mean, after 1 week, 10 days, I stumbled over a solution that brought the render time down to something like 1/3 without increasing the memory too much. So the second lesson, small things matter if you repeat them lots of times, matter for better or for worse, of course. And the lesson 3. Now I wasn't feeling too dumb anymore, but my engine was still much slower than what other people following the same steps were building. I was following kind of a tutorial in a book. My pride was being hurt a little bit, and I thought it was the right time to try web workers, and it worked beautifully. In the worst case, the render time went down by half. And now I have my third lesson. It's always your fault. And the other lesson is that web workers are cool. So let's take a quick look at it. According to MDM, web workers are a single means for web content to run scripts in background threads. The worker thread can perform tasks without interfering with the user interface. That's a pretty straightforward explanation, and I think everyone gets it. But some things to pay attention to: workers run a named JavaScript file. They run in another global context that is different from the current window. You can't directly manipulate the DOM from a worker. The way I used it in my ray tracer was splitting the canvas size I wanted to render into the number of threads available. Each worker has instructions to process just one part of the image. When the job is done, it returns the result to the main thread using the post message function. Here it is my worker JS file where I render the job and call post message with the result. We can see that it's pretty simple. We don't need to import post message from anywhere. I just do the work. I render the part of my image and I send it back to my main thread just using the post message function. And on the below that image, on the main.js file, I initialize the worker, send the message with instructions, and listen for the result of each worker. We see some things, but it's pretty straightforward. I just initialize the workers, passing the name of the file, the path of the file. On the for each, I just post a message with the instructions I want each worker to have, and when it finishes, I get the message listening on the worker.onMessage, and I display the results on the screen. So let's take a look really quick at a live example. Here's one of the things that I've built. We can see that the ray tracer is taking 5.4 seconds to render this image using 12 workers. But we can play a little bit with it, performance tab, hardware concurrency. Let's see how much it takes to render with just two refreshing the image, the page, sorry. And it's taking a little bit more to show things on the screen. So it takes like more than double of the time using two workers. We can see here in another example that we render the image not in a chronological order. As soon as one worker finishes its job, it starts changing the pixels on the canvas. So it's taking a little bit of time. Let's see. Sorry. Fuck. Yeah, let's just close this because I need to switch to 12 workers again. Yeah, it's gonna work. I think otherwise it would take like more than 1 minute to render. So almost there. Almost there. So we can see now that's started rendering the image, and it doesn't have a order. It's just when the faster the worker, the more priority it has. One more to go, and that's it. 36 seconds using 12 workers. Yeah. So let's continue with the slides. Let's just see what okay. Okay. So having workers up and running is kind of relatively simple, but sometimes we will need to measure if shared workers are better than dedicated ones, if the communication between the main thread and the background thread will be done by copying data or passing references, or if the architecture will scale. Using libraries won't free you from going through these decisions, I'm sorry, but certainly will make things a little bit easier. For example, we have here the comlink. There's a tiny library that helps with the communication between threads, and it uses RPC under the hood to make data available to them as if it were a local value. So you can see that we just initialize the worker as I've done before. We wrap it with the comlink, but the difference is we can use the worker method like if it were just a async function, which makes things much simpler when structuring a application, at least for I don't know, for the first times you try it. So I've learned some interesting things going through this process, and some of them are like the first one, performance can have different meanings in different contexts. Switching between my ray tracer and the micro interactions challenge made me think about my way of dealing with some problems. Second one is small things matter if you repeat them lots of times. A bad thing, not bad thing, but bad thing that I did with that string interpolation when rendering my my first image took 1 week of my life. So just because of small things I've done, I suffered a bunch. And the third lesson is if something is wrong, it's always your fault. I know it sounds like kind of a coach motivational speech, but if you don't believe that we can change, that we can do better, that we can change something, could be the loading time of our app or changing someone's day by saying that we appreciate them. If you don't believe that something is possible, we shouldn't expect that other people will do that for us. Those are all cliche, but it's different when you have a chance to sit live rather than just thinking about it. And to not close with too much theory, I want to leave a list of things that we are a bit closer to do, that we do in our day-to-day, and could be done with web workers. I'm not gonna read all of it, but one that I think it's pretty cool, and probably I'm not gonna do anytime soon, at least, is that we can load and run JavaScript libraries inside a worker and free the main thread of downloading and parsing this code. So I know I can think of some situations where it could be useful, but I don't know. I think it's just pretty cool to have this possibility of using web workers in our day-to-day problems. And that's it. Thanks for your time. And do you have some questions, some suggestions, anything? I'm gonna stop sharing.
I just want to say, man, I love this. It was like just abstract enough to like tingle my brain and make me think about things. It's very good. I wanted to bring up something. I think you hit the nail on the head. Small operations become costly over time. When I went to the Confident SF, I sat in on a talk on performance and optimization, and somebody